Lesson 11, Operational Amplifier, Applications. Section 11.4. Subtracting Amplifier. Experiment 11.4. Pause the video, and follow the instructions. This is to test a subtracting amplifier. Measure V1, V2, and V3. And find the voltage gain AV. Pause the video, and check the results. The absolute value of V1 minus V2 was almost equal to the absolute value of V3. Therefore, this amplifier is called a subtracting amplifier. Exercise 11.4. This is your homework. Pause the video, and answer the problem. You can solve this problem by following the hints. Section 11.5. Integrating Amplifier. Experiment 11.5. Pause the video, and follow the instructions. This is to test an integrating amplifier. Measure V1 and V2. These are the results. V1 is the input, and V2 is the output. A DC component was contained in V2. By removing the DC component from the V2 data, we can find that the remainder of V2 is a cosine function. This is what the amplifier did. The input was a sine function. The amplifier integrated and inverted the sine function. The output is a cosine function. The amplifier has a resistor labeled R2. If R2 is removed, what will happen? This was the result. The DC component in V2 increased. When saturation was observed in V2, the DC component stopped increasing. In the actual circuit, a small amount of DC component is contained in V1 and or AVOP, and the integrated value of the DC component is proportional to time. If R2 is connected in parallel to C1, it bypasses the DC component to avoid saturation. The analysis of this integrating amplifier also begins with the concept of a virtual short. The analysis follows the same method as that of an inverting amplifier. The only difference is Vc, which is the integrated value of I2. Exercise 11.5. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.